Question 15, we have a card is drawn at random from a standard pack of 52 playing cards. First, we will define the standard pack of 52 playing cards in detail. The standard pack of 52 playing card has four suites like clubs, spade, diamonds, and hearts. And each suite has 13 cards like ace, 2, 3, up to 10, jack, queen, and king. Clubs and spades are black, and diamonds and hearts are red. Now we have to find out the probability that a card is black that is drawn. Since all the clubs and spades are black, so there are 13 spades and 13 clubs. So 13 add 13 divided by 52, and that will be equals to 26 over 52. And after simplification, it will give us 1 over 2. So the probability of drawing a black card is equals to 1 over 2. Now the part 3, we have to find out the probability of a spade that is will be equals to 13 over 52. Since the number of spade in a standard pack of 52 playing cards is 13 as we have discussed, so it will be simplified to 1 over 4. So the probability having a spade is equals to 1 over 4. Now in the part 4, we have to find out the probability that a card which is not a spade will be find out simply by just take away the probability of a spade from 1. So 1 take away 1 over 4, and that will be equals to 4 minus 1 divided by 4, and that will be simplified to 3 over 4. So the probability a card which is not a spade is equals to 3 over 4. Now in the question 16, a two-digit number is randomly formed using the digit 1, 4, and 6. Repetition of digit is allowed. So in the part 1, we have to list the sample space in set notation. So for part 1, we have S is equals to, with the help of 1, we can write 11. With the help of 1 and 4, we can write 14. Similarly, 16. Now with 4, 1, we have 41. With 4, 4, we have 44. With 4, 6, we have 46. Similarly, 61, 64, and 66. Now, in the part B, in the part 2, by using set notation for the respective events, find the probability that the two-digit number formed is divisible by 3. Let A be the event that the two-digit number formed is divisible by 3, then A is equals to 66. Now to find the probability of the event A, we will use the formula. The probability of A will be equals to n of A divided by n of S. Since the number of element in the event A is 1, and the number of elements in the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability that the two-digit number formed is divisible by 3 is equals to 1 over 9. Now in the part B, we have to find out the two-digit number formed is a perfect square. So let B be the event that the two-digit number formed is a perfect square. So what is meant by perfect square? A positive integer that is obtained by multiplying an integer by itself is a perfect square. So here 16 and 64 are the perfect squares. So the elements in the event B will be 16 and 64. Now to find out the probability of event B, we will use the formula n of B divided by n of S. 9. So the probability for the event B is equals to 2 over 9. Now in the part C, we have to find the probability that the two-digit number formed is a prime number. Since the prime number is the number that has only two factors, 1 and itself only. So let's see with the event that the two-digit number formed is a prime number. So then C is equals to 11, 61, and 41. So the probability of event C can be obtained by using the formula N of C over N of S. The number of element in the event C is 3, and the total number of element in the sample space is 9. So 3 over 9 will be simplified to 1 over 3. So the probability for the event C will be equals to 1 over 3. In the part D, we have to find out the probability that the two-digit number formed is a composite number. So let D be the event that the two-digit number formed is a composite number. But first we will see what are composite numbers. A number that has more than two factors are known as composite numbers. So first we will highlight the composite number in the sample space. Here we have 14, 16, 44, 46, 64, and 66. So now the event D has element 14, 16, 44, 46, 64, and 66. And now we can find out the probability of the event D by using the formula N of D divided by N of S. And the number of elements in the event D is 6, and the number of elements in the sample space is 9, and that will be simplified to 2 over 3. So the probability for the event D will be equals to 2 over 3. In 17, we have A, B, C, D, E, F is a regular hexagon. Hexagon is a six-sided 2D shape with center O. M is the midpoint of AB and N is the midpoint of BC. A point is selected at random in the regular hexagon. Find the probability that the point lies on the kite M, B, and O. Okay, so first we have drawn a hexagon having the vertices A, B, C, D, E, F, and having center O, and M and N be the midpoints of the sides A, B, and B, C respectively. And now we can see the kite in the hexagon, in our drawn hexagon, and that is M, B, and O. Okay, so for this, we will have the area of MOB. The area of MOB is equals to the area of NOB. So for this, the area of MOB is equals to the area of NOB. The area of NOB is equals to half of the area of AOB. And since we know that the area of AOB is equals to 1 over 6 of area of hexagon. So after simplification, we have 1 over 12 into area of hexagon. So the area of MOB is equals to 1 over 12 into area of hexagon. Since we have to find that the probability that the point lies in the kite MBNO. So for this, we will use the formula area of MBNO divided by area of hexagon. Since the area of MBNO is equals to the area of MOB plus area of NOB divided by area of hexagon, so it will be equals to, since we have find out the value of area of MOB, and that was 1 over 12 into area of hexagon plus, again, the area of NOB is equals to 1 over 12 into area of hexagon, and that is divided by area of hexagon. And then we add up 1 over 12 into area of hexagon plus 1 over 12 of into area of hexagon, and that will be add up to 1, gives us 1 over 6 into area of hexagon divided by area of hexagon. And the area of hexagon is cancel out with the area of hexagon in the denominator, and it is simplified to 1 over 6. So the probability the point lies in kite MBNO is equals to 1 over 6. Now in the question 18, in an experiment, two spinners are constructed with spinning pointers as shown in the diagram below. Both pointers are spun. Each time the pointer is spun, it is equally likely to stop any sector. So here we have first pointer having 5 sectors and a second pointer also having 5 sectors. In the part 1, find the probability that the pointers will point at numbers on the spinner whose sum is 6. So first we have to find out the number of possible outcomes. Since the first spinner have 5 sectors and the second spinner also have 5 sectors, so 5 times 5 is equals to 25. So the number of possible outcomes will be equals to 25. Now we have to find out the probability that the pointers will point at numbers on the spinner whose sum is 6. So the probability that the sum is 6 will be equals to the probability of 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. So here we can see we have 5 favorable outcomes. So the number of favorable outcome is 5 and the total number of outcome is 25. So after multiplication, it will become 1 over 5. So the probability that the sum is 6 is equals to 1 over 5. Now in the part B, we have to find out the probability that the pointers will point at the same number on the both spinners. Since we have 5 numbers, 1, 2, 3, 4, 5, so the number of favorable outcomes again is 5, and the total number of outcomes in the sample space is 25. So it will give us 1 over 5. So the probability that the same number will be equals to 1 over 5. Now, the probability we have to find that the different numbers on the spinners. So since we have find out the probability of for the same number, so the complement of this event will be the probability of the different number equals to 1 minus probability of same number. So this will be equals to 1 minus 1 over 5, and it will becomes 5 minus 1 over 5, and it will be simplified to 4 over 5. So the probability that the pointers will point at different numbers on the spinners is equals to 4 over 5. Now in the part D, we have to find out the probability that the pointers will point at two different prime numbers. So two different prime numbers are 2 and 3, 2 and 5, 3 and 2, 3 and 5, 5 and 2, 5 and 3. So here we have 1, 2, 3, 4, 5, and 6 possibilities. So the probability that two different prime numbers, the pointers will point is 6 over 25. In the part 2, what is the probability that the number on the first spinner will be less than the number on the second spinner? So the probability that the number on the first spinner is greater than the number on the second spinner will be equals to 1 and 2, 3, 4, or 5, 2 and 3, 4 or 5, 3 and 4, or 5, 4 and 5. Since we can see that here we have 10 possibilities, so the probability that the number on the first spinner is greater than the number on the second spinner will be 10 over 25. And after simplification, it will give us 2 over 5. So the probability that the number on the first spinner is greater than the number on the second spinner is equals to 2 over 5. Now in part 3, we have to find out what is the probability that the larger of the two numbers on the spinner is P. So the probability for the larger of the two number is 3. It means if we have two numbers, the larger one is always 3. So here we have the numbers 1 and 3, 2 and 3, 3 and 1, 3 and 2. So if we count the possibilities, there have 1, 2, 3, 4. Favorable number of favorable outcomes is 4, and the total number of outcomes was 25. So the probability if for the P larger of the two numbers is 3 is equals to 4 over 25. Now in question 19, in a game, the player tosses a fair coin and rolls a fair six-sided die simultaneously. If the coin shows a head, the player's score is on is the score on the die. If the coin shows a tail, then the player's score is twice the score on the die. So some of the player's possible scores are shown in the sample space diagram. For part 1, copy and complete the sample space diagram. Since it is given that if the coin shows a head, the player scores is the score on the die. So if we have head, then the coin shows 1, 2, 3, 4, 5, and 6 on a fair six-sided die. And if the coin shows tail, then the player score is twice the score of on the die. So if we have tail, then we have 1. No, it will become twice. So here we have 2, and twice of 2 is 4, twice of 3 is 6, twice of 4 is 8, twice of 5 is 10, and twice of 6 is 12. So this is the complete sample space diagram. Now in the part 2, using the sample space diagram, find the probability that the player's score is odd. So in the part A, we have to find out that probability of score is odd. So first we will underline the outcomes that tells us about the score is odd. So here we have 1, 3, and 5. So the favorable number of favorable outcomes is 3. Now we will count the total number of outcomes. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of outcomes is 12, and it will give us 1 over 4. So the probability that the score is odd is 1 over 4. Now to find out the probability of the score is even, we can simply have to subtract the probability of the score is odd from 1. So for this, we will do 1 minus 1 over 4, and it will be equals to 4 minus 1 over 4. And it will be simplified to 3 over 4. So the probability that the score is even is equals to 3 over 4. Now in the part C, we have to find out that the player score is a prime number. So what are prime numbers? A number that has only two factors, 1 and itself, are known as prime numbers. So here are the prime numbers. We will highlight those numbers with black. So 1, 2, 3, 5. So here we have 4 prime numbers. So from this, the number of favorable outcomes is 4, and the total number of outcomes are 12. So it will be simplified to 1 over 3. So the probability that the score is prime is equals to 1 over 3. So the probability that the score is prime number is equals to 1 over 3. Now in part D, we have to find out that the probability of the player score is less than or equal to 8. And so the probability that is less than or equals to 8 will be equals to, first we will have to mark the scores that are less than or equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here are the 10 scores that are less than or equals to 8. So the number of favorable outcomes is 10, and the number of total possible outcomes is 12. So it will be simplified to 5/6. So the probability that the score is less than or equal to 8 is 5/6. For the party, we have to find out the probability that the score is a multiple of 3. So for this, we need to find out the numbers in the sample space diagram that are the multiples of 3. So here we have 3, 6, and 12. So the number of favorable outcomes is 4, and the number of total possible outcomes is 12. So it will be simplified to 1/3. So the probability that the score is a multiple of 3 is equals to 1/3. Question 20. Two fair 6-sided dice were rolled together, and the difference between the numbers on their face was calculated. Some of the differences are shown in the sample space diagram below. Now in the part 1, copy and complete the sample space diagram. So 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and 6 minus 1 is 5. Similarly, along the vertical axis, we have 1, 2, 3, 4, and 5. Now 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3. Similarly, along the horizontal axis, 4 minus 2 is 2, 3 minus 2 is 5 minus 2 is 3. 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2, 6 minus 3 is 3. Similarly, horizontally, 4 minus 3 is 1, 4 minus 4 is 0, 5 minus 4 is 1, and 6 minus 4 is 2. Now for the next, 5 minus 3 is 2. 5 minus 4 is 1, 5 minus 5 is 0, 6 minus 5 is 1. And for the last one, 6 minus 3 is 3, 6 minus 4 is 2, and 6 minus 5 is 1. And then the part 2. So in the sample space diagram, find the probability that the difference between the two numbers is 1. So the probability that the difference is 1, we have to count the differences that are 1 from in the sample space diagram. So we will mark over required favorable outcome with red. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the number of favorable outcomes is 10. And the total number of outcomes is 36. So it will be simplified to 5/18. So the probability that the difference is 1 is equals to 5/18. Now in part B, to find the probability that the difference is 0, we simply take away the probability that the difference is 0 from 1. And we will get the probability that the difference is non-zero. So we will mark the outcomes that are 0 in our sample space diagram. So here we have 1, 2, 3, 4, 5, and 6. So the number of favorable outcomes is 6, and the number of total outcomes is 36. So it will become 1/6. And it will simplify to 1 minus 1/6. And it will give us 5/6. So the probability that the difference is non-zero is equals to 5/6. And then the part C, to find out that the probability is difference is odd. So we will mark in the sample space diagram with green. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Favorable outcomes is 18 and the total number of outcomes is 36. It will be simplified to 1/2. So the probability that the difference is odd is equals to 1/2. So the probability that the difference is greater than 2 is equals to 12/36. And it will be simplified to 1/3. So the probability that the difference is greater than 2 is equals to 1/3. Question 21. A bag contained 3 cards, numbers 1, 3, and 5. A second bag contained 3 cards, numbered 1, 2, and 7. One card is drawn at random from each bag. In the first part, we have to display all possible outcomes of the experiment using a tree diagram. So for the first card, we have 1, 3, 5, and 7. And for the second card, we will start from the 1 of the first card and we will get 3 possibilities, 1, 2, and 7. Similarly for 3 and similarly for 5. So the total number of outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9. And according to the question's requirement, we have to find out the sum and products as well. So the product of 1 and 1 is 2, 1 and 3 is 3, 1 and 7 is 4. Similarly, the other sums can be calculated. Similarly, for the products, 1 times 1 is 1, 1 times 2 is 2, 1 times 7 is 7, 3 times 1 is 3, 3 times 2 is 6, 3 times 7 is 21. And similarly, the remaining products can be found out. So this is the display of all the possible outcomes of the experiment using the tree diagram. Now for question 22, part 2, so part A, we have to find out the probability that the both numbers are odd. So the probability that the both numbers are odd is 6. And the total number of outcomes we have calculated are 9 from the tree diagram. So here we have 2/3, and the probability that the both numbers are odd is equals to 2/3. Now in the part B, we have to find out the probability that the both numbers are prime numbers. So here we have 4 favorable outcomes, 3 and 2, 3 and 7, 5 and 2, 5 and 7. So the number of favorable outcomes is 4 and the total number of outcomes are 9. So the probability that the both numbers are prime numbers is equals to 4/9. Now the part 3, we have to find out that the sum is greater than 4. So we will highlight the sums that are greater than 4, that are 8, 5, 10, 6, 7, and 12. So we have 6 numbers of favorable outcomes, and it is divided by the possible number of outcomes. So it will be simplified to 2/3. So the probability that the sum is greater than 4 is equals to 2/3. Now on the part D, to find out that the sum is even, so we will mark the even sums with black. So we have 2, 8, 4, 10, 6, and 12. So 1, 2, 3, 4, 5, 6. Favorable numbers of outcomes is 6, and the total number of possible outcomes is 9, and it will be simplified to 2/3. So again, the probability that the sum is even is equals to 2/3. Now in part E, we have to find out that product is a prime number. So we have to mark the numbers in the product list that are prime. So we have 1, 2, 7, 3, and 5. So the number of favorable outcomes is 4. And the total number of outcomes is 9. So the probability that the product is a prime number is equals to 4/9. Now in the part F, we have to find out that the product is greater than 20. So we will mark the products that are greater than 20 with black. So here we have 3, 1, and 35. So the number of favorable outcomes is 2, and the possible outcomes are 9. So the probability that the product is greater than 21 is 2/9. Now, in the part D, we have to find out the probability that the product is divisible by 7. So in the product list, we have to mark the numbers with the green that are divisible by 7. So here we have 7, 21, and 35. So the number of favorable outcomes is 3, and the total number of outcomes are 9. So it will be simplified to 1/3. So the probability that the product is divisible by 7 is equals to 1/3. Now, the 22, the elements of eta, of P, and of Q are shown in the Venn diagram below. An element is selected at random. Find the probability that the selected element is an even number. So in the first part, since event E is a proper subset of set eta, so let E is equals to 2, 3, 4, 6, and 8. So the number of elements in the event E are 5, and the total number of possible outcomes we can see from the Venn diagrams are 10. So first we will write the formula, since we have n of E over n of eta. And now it will be equals to 5/10, and after simplification, it will gives us 1/2. So the probability that the element is an even number is equals to 1/2. By part 2, we have to find out the probability that a number not in P or Q. So in other words, we have to find out the probability of the P union Q Hall complement. So for this, we have the number of elements in the P union Q Hall complement divided by number of elements in set eta. So those are 3. and the total number of elements in the set eta are 10. So we can mark the 3 favorable outcomes that we can see in the set eta. So the probability for the P union Q Hall complement is equals to 3/10. Let R be an event that an element is a prime number. So for this, take a proper subset of set eta, and the set R is equals to 2, 3, 5, and 7. So the probability for R is the number of elements in the event R divided by number of elements in the set eta. Since the number of elements in the set R are 4 and the number of elements in the set eta is equals to 10, and it will be simplified to 2/5. So the probability for the event R is equals to 2/5. The part 4, a prime number. We have to find the probability that the selected element is a prime number in Q. So for this, we have to find out the probability of R intersection Q, the number of elements in the R intersection Q divided by number of elements in the set eta. Since we can see that the number of elements in the R section intersection Q are 2, and the number of elements in the set eta are 10. So it will be simplified to 1/5. So the probability for the R intersection Q is equals to 1/5. Question 23. A fair coin and a fair six-sided die are tossed and rolled respectively. Using set notation, this is the sample space of the experiment. So for this, let S be the sample space, having the ordered pairs. So the first order pair is head 1. The second is head 2. The third is head 3. The fourth is head 4. The fifth is head 1. Head 5. The sixth is head 6. The seventh order pair is tail 1. The eighth order pair is tail 2. The ninth order pair is tail 3. The 10th order pair is tail 4. The 11th order pair is tail 5. And the 12th order pair is tail 6. So we have 12 order pairs in the sample spaces. 24. Hotel Y is a 2-story hotel with rooms and their respective room numbers arranged as shown in the diagram below. Rooms are allocated at random when guests arrive, and each guest is allocated 1 room. Cheryl and Joyce arrive at Hotel Y on a particular day. Upon their arrival, none of the rooms in Hotel Y are occupied. In the part 1, with the help of a sample space diagram, find the probability that the Cheryl and Joyce stay next to each other. So first we will have, now to draw the sample space diagram, we will put the 1A, 1B, 1C, 2A, 2B, and 2C on the horizontal axis, and similarly 1A, 1B, 1C, 2A, 2B, and 2C on the vertical axis. And we will don't draw any circle having the same hotel room. For example, we will not put any dot for 1A and 1A, similarly for 1B and 1B, similarly for 1C and 1C, for 2A and 2A, for 2B and 2B, and for 2C and 2C. And we will draw the dots for the remaining order pairs. So with the help of the sample space diagram, we have to find out the probability that the chiral and Joyce stay next to each other. For the part 1, first we will find out the total number of possible outcomes. So we can see from the from the sample space diagram that the total number of possible outcomes is equals to 30. Now for the part A, we have to find out the probability of chiral and Joyce. So we have to mark the order pairs that shows the chiral and Joyce stay next to each other, just like, for instance, we have 1A and 1B, 1B and 1A. Similarly, 1B and 1C, 1C and 1B. Here the possible number of outcomes are 8, and the total number of outcomes are 30. And after simplification, it will give us 4 over 15. So the probability that the chiral and Joyce stay next to each other is equals to 4. The part D, we have to find out the probability that the chiral and Joyce stay on different stories. So here we have marked the order pairs that shows that chiral and Joyce stay on different stories by triangles in pink color. So here we have 1A and 2A, 1B and 2A, 1C and 2A, 1A and 2B, 1B and 2B, 1C and 2B. Similarly, 1A and 2C, 1B and 2C, 1C and 2C. So if we count the variable number of outcomes, so they are 18. And the total number of outcomes was 30. And after simplification, it will give us 3 over 5. So the probability that chiral and Joyce stays to different story is equals to 3 over 5. Now in part C, we have to find out the probability that Joyce and chiral do not stay next to each other. So for this, we just have to subtract the probability of chiral and Joyce stay next to each other from 1. So for this, we have 1 minus 4 over 15. And after simplification, it will give us 15 minus 4 over 15. And it will be equals to 11 over 15. So the probability that the chiral and Joyce do not stay next to each other is equals to 11 over 15. Now in the part 2, we have to suppose the hotel accepts chiral's request that she only wants to be allocated rooms on the second floor. What is the probability of her staying next to Joyce? So since the hotel accepts the chiral's request to allocate a second story room to her, the total possible outcomes is now 15. Now we have to find out the probability Charles stays on second story and is beside Joyce. So here we have only 4 possible outcomes that we have marked with blue circles. So the favorable number of outcomes is 4 and divided by total number of outcomes, that is 30. And after simplification, but in this case, we have total number of outcomes is 15. So the probability that the chiral stays on second story and is beside Joyce is 4 over 15. Now the question 25. 2 fair tetrahedral dice and a 6 fair-sided die are rolled simultaneously. The numbers on the tetrahedral dice are 1, 2, 3, and 4, while the numbers on the 6-sided dice are 1, 2, 3, 4, and 5, and 6. What is the probability that the score on the 6-sided die is greater than the sum of the scores on the 2 tetrahedral dice? So the possibility diagram below shows the possible sums of the scores on the 2 tetrahedral dice. So here we have 1 add 1 is 2, 2 add 1 is 3, 3 add 1 is 4, 4 add 1 is 5. Similarly, we have got the different outcomes that we can see in the diagram, and there are the total of 16 possible outcomes. The possibility diagram below shows the possible outcomes of the sum of the scores on the two tetrahedral dice and the score on the six-sided die. There are a total of 96 possible outcomes. So on the vertical axis, we have sum of scores on the tetrahedral dice, and on the y-axis, we have the score on six-sided dice. And those are 1, 2, 3, 4, 5, 6. And on the horizontal axis, we put the numbers that we have seen in our previous diagram. So there are 2, 3, 3, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 7, 7, and 8. And we have drawn the dots for the possible outcomes. And now we will mark the outcomes that shows only the score on the six-sided die is greater than the sum of the scores on the two tetrahedral dice. So now to find out the probability that the score on the six-sided die is greater than the sum of the score on the two tetrahedral dice, we can clearly count the number of favorable outcomes, and that are 20. And the total number of outcomes are 96. And after simplification, it will give us 5 over 24. So the possibility that the score on the six-sided die is greater than the sum of the score on the two tetrahedral dice is equals to 5 over 24. Now in the question 26, the one diagram shows the number of elements of eta, of A, of B, and of C. It is given that the number of elements in the set eta is equals to 48, and the number of elements in the set A intersection B is equals to number of elements in the C complement. So in the part 1, find the value of x and of y. So for this, we will add up all the information that we can see in the Venn diagram and put it equals to 48. So here we have 1 plus 3 plus 8 plus 5 plus y plus 1 plus 2x plus 3x equals to 48. And after simplification, it will become 5x plus y and plus 18 is equals to 48. And in the next step, this 48 and this plus 18 goes on the other side, will become minus 18. And we have 5x plus y is equals to 48 minus 18. And our equation will become 5x plus y equals to 30. And this will be our equation 1. Since we have the second equation given in the question that n of A intersection B is equals to n of C complement, since we can see that the n of A intersection B is equals to 3 plus y and n of C complement is equals to 2x plus 1 plus 3 plus 8. And after simplification, we will get 3 plus y equals to 2x plus 12. And after further simplification, we have 2x minus y equals to 12 minus 3. And now we have 2x minus y equals to minus 9. This is our equation 2. We're adding the equation 1 and 2, and we get 7x plus 21. And this 7, when goes on other sides, it will divide the 21, and it will give us 3. So the value of x is equals to 3. Now put this value of x in the equation 1. So 5 into 3 plus y is equals to 30, and it will become 15 plus y equals to 30. And when this 15 goes on the other side, it will become minus 15, and the value of y is equals to 15. So hence the value of x is equals to 3, and the value of y is equals to 15. When element is selected at random, then find the probability of C. To find the probability of C, we'll use the formula. The probability of C is equals to probability of C divided by probability of the set eta. So the number of elements in the set eta are 5 plus y plus 1 plus 3x divided by 48. And it will be simplified to 3x plus y plus 6 over 48. The values of x and y that we have found out in the part 1, and after adding up, we will get 30 over 48. After simplification, we will get 5 over 8. So the probability for the C is 5 over 8. 6 part B, we have to find out the probability of A union B. So for this, we will use the formula of probability of A union B is equals to number of elements in the set A union B divided by number of elements in the set eta. So the number of elements in the set A union B is equals to 48 minus 2x minus 3x, and the number of elements in the set eta is equals to 48. And after simplification, it will become 48 minus 5x over 48. And we will put the value of x, and that was 3. And it will become 48 minus 5 into 3 divided by 48. Now it will become 48 minus 15 over 48. And 48 minus 15 is equals to 33 divided by 48. And after simplification, it will give us 11 over 16. So the probability of A union B is equals to 11 over 16.